It is such a privilege to come and speak to everyone here today at Microsoft. My name is Rafa Knight, or you can refer to me as Raf or Rafa. I honestly respond to most things. So super excited to come and speak to you all today. As Liam mentioned, I head up an organization called Secure.ai. We work across public and private sector, and we help organizations to think about security when they're adopting AI. And with the way that things have happened, actually what we're seeing is that organizations have already adopted AI and now they're going, shit, it's not secure, we need help. So it's not the way that we normally run things. But I'm going to say hello, Microsoft, and I want everyone to say hello back because we need to bring the energy up in this room a bit. So hello. Hello. I know we can do better. Hello. Hello. One more time. Hello. Hello. Okay. I think that's as excitable as I can get an IT bunch. So let's get into it. So I'll tell you a little bit about who I am, who we are, what we do. You already know a little bit about the work we do with AI. But my background is in consultancy. So I used to work at EY and supported sort of public and private sector clients in cybersecurity. And then sort of moved on and set up my own firm. And now we do sort of AI and cybersecurity, which is really, really exciting. There's a real vision and mission to what we do, which is we believe that AI should work for 8 billion people, not just 8 billionaires. And so part of what we do is we also go out into communities for free to educate vulnerable people on online safety, because we believe everyone should understand how to be safe online. Now, in terms of our, there we go. In terms of our agenda, we've got definitions, what is the problem, looking at OECD, looking at NIST, EU AI Act, use cases, and let's connect. Now, I'm aware this is a very technical room. We're going to be taking slightly more of a security GRC approach, but we're going to enjoy it. We're going to learn together, and it's going to be super fun. Now, before we start, I'm going to tell you 3 really, really important facts. I'm actually Dutch, as you can tell from my really strong English accent. I love cybersecurity, evidently, because why would you go through the effort of setting up a cyber consultancy if you don't? And number 3 is the most important fact. I love Labradors. I think that they are the most incredible pet in the whole world. And if you stay tuned, you might see a nod here and there. So let's start. Now, what is the problem? And what does the threat landscape look like? Now, from the organizations that we've worked with, and this is sort of what we're seeing, 73% of organizations don't have a formal AI policy in place. Now, from a security perspective, what that means is data isn't secure within the organization. It can leave through AI tools, and this is through off-the-shelf AI. So the danger here is when you have AI that you're paying for, it will go through a procurement process or a third-party process. But when you're having off-the-shelf free AI, which anyone has access to, it is much more difficult to manage your data and security. So that's problem number 1. And as you can see, it's a pretty big problem. Now, problem number 2 is 76% of current Gen AI projects are not being secured. Now, Liam kindly, in his introduction, mentioned sort of that developers don't always think about security. And from my experience, this is very much true. So when you're developing and you're engineering and you're designing, people are not always considering security. And actually, up until recently, that isn't something that we would have put in that sort of bucket for that role. So now developers and engineers are having to think about security whilst they're designing. And then finally, we're also seeing that organizations surveyed stated that AI-powered cybersecurity attacks are a major challenge. And this is what we're also hearing from in-house SOC teams. So they are really struggling to manage security around AI. Now, what is the impact? We know that 83% of customers surveyed reported that they would take their business elsewhere following a security breach. And that translates into a direct reputational financial impact from not securely managing your organization. And we're seeing that that's driven really heavily by the adoption of ungoverned and unsecured AI. Now, we also know that 87% of organizations in the UK are vulnerable to AI-powered cyber attacks. That's a really interesting number because That number, I believe, came from Microsoft, from some research that Microsoft did. So there we go. And then we also know that the average cost of a data breach is 4.45 million. Now, what do the cyber professionals think? 95% agree that sort of you need AI-powered cyber solutions to sort of solve AI-powered attacks. And what we'll look at later on together as well is what are some of those applications and how can we leverage AI to manage security? And we also know that 96% of organizations surveyed reported seeing more sophisticated cyber attacks. Something that we're seeing is that employees who traditionally would have passed their phishing training are now starting to fail because the attacks are becoming a lot more sophisticated and a lot more difficult to spot. Now, what we do at Secure AI is we do AI security workshops, AI security assessments, and then AI security policies, strategies, target operating models, etc. Now, our AI cyber workshops are also geared towards a security audience. So if you're an in-house security person, or if you're a developer engineer and you want to know, how do I manage cybersecurity within my role? How do I make sure I'm developing, engineering, designing securely? We come in and we do that training, and it's personalized training. So that's a little bit more about kind of what we do. We have 25 minutes, I believe, so we're not going to go through all these definitions, but can I get a hands up? Who, put your hand up if you are 100% comfortable with all the definitions on the board. Okay, 90%. Yeah, 80%, 70%, 60, 50, 40. Okay, this is great. So I'm glad these are up there. So these definitions are all taken from best practice. So things like OECD, EU AI Act. But when we're talking about AI, I'll just read out this one definition. Otherwise, we would be here till tomorrow. So AI system is a machine-based system that, for explicit or implicit objectives, infers from the. I'm not going to continue reading because you don't want to hear me reading off the board. Instead, I think I might just show you a slide with pictures and examples. Is that more fun? Yeah, nodding. I'm getting engagement. This is fun. Great. I've circled this because from a security perspective, a report by Ofcom came out, and they did lots of really important research over the last year, and they found that one of the number one AI security-driven threats that they're seeing is actually deepfakes. And so we've got examples of how CEOs have been impacted, organizations have been impacted, but in terms of what is materializing from an AI security-driven threat, deepfakes are what we're seeing the most of. So keep that one in mind. Now, pictures with examples. There we go. So when we talk about general purpose AI and narrow AI, one of the key distinctions is that narrow AI is designed to do one task, whereas general purpose AI is designed to do more than one task. That is a huge oversimplification of that definition. But what is really important to note is that what goes into this bucket, according to the EU AI Act, isn't necessarily what scientists would agree with. So to be cautious and to be risk-based, from a regulatory perspective, things have been put into the GPAI, which is general purpose AI bucket, even though a scientist may not necessarily agree with that, but that is just to be cautious. So examples of general purpose AI would be things like ChatGPT, DALL-E, Google Bert, I've put Microsoft Copilot there, Midjourney, narrow AI, might be Alexa, Siri, weather forecasting, Google Assistant, and then generative AI. We have ChatGPT, DALL-E, Jasper. Put your hands up if you've used any of these. Okay, amazing. Put your hands up and be honest, because I don't think anyone's watching the room. I think they're just watching me, right? So it's okay. And if they're watching you, just ignore it. Put your hands up if you thought about security when you use those tools. Okay. Yeah, someone in the audience did this, and I think that was a very honest individual. Great. Now, oh, look at that. A picture of a Labrador. There we go. Move on. We're about to get into some really heavy regulatory stuff, but you've been warned. Now, from an OECD perspective, put your hands up if you're familiar with OECD. Okay, cool. Liam, I can see your hand constantly going up. Do you want to help present this? Now, the OECD essentially set standards, and they've set standards around AI and best practice. And they've come up with these 5 principles. And when you're doing things around engineering and developing, it's really important to think about these 5 principles. Now, we've worked with organizations where we've gone in and we've helped those teams adopt these principles so that they're not having to go back and redesign work down the line, which takes a lot more time, but they can do it as they're building and designing. So the first one is around inclusive growth, sustainable development and well-being. The next one is around human-centered values and fairness. The third one is around transparency and explainability. Now, this is really important because within the UK, we've seen sort of guidance coming out from the ICO, which is the Information Commissioner's Office, and they look at sort of financial institutions and all that jazz. And what they've said is that organizations must have explainability. So that means if you're an engineer and you're a developer, right, and we go back in that life cycle, you're actually building and creating. Can you turn around and explain how an AI model made that decision? Because from a regulatory perspective, that's now being looked at and required. So actually, the work you're doing is so incredible when you're building, but also are you considering explainability as part of that, transparency as part of that? That's really important. Next, we've got robustness, security, and safety. This, again, has been called out across regulation, across best practice. From a sort of robustness, security, and safety perspective, they're also just looking at things like operational resilience. How resilient is it? Put your hands up if when you're developing or engineering, you're thinking about something like a business continuity plan. So I'm glad no one put their hands, well, I'm not glad no one put their hands up, but do speak to me afterwards. But this is precisely the problem, because what we're seeing is happening is we're not thinking about business continuity. A model goes out, an organization is using it, and something happens. But then from a business continuity perspective, how do we make sure that customers, the organization, the data are secure and protected? How do we make sure that there's a plan in place? How do we make sure we can get back up and operating again? Next, it's looking at accountability. So this is looking at organizations and individuals developing, deploying, or operating AI systems. Interesting, individuals developing or deploying or operating AI systems. So again, that would be people like you guys who are the engineers, the developers, the technical people working on this. Now, next we're looking at NIST AI RMF. Put your hands up if you're familiar with NIST. Cool, Liam. Need to be handing cookies over. So NIST is a US standard, and what they normally produce and what they have continued producing is something called the CSF. And so the CSF, where you work, you'll have a GRC function, which is your governance, risk, and compliance function, or you might just have a risk function, and they'll go on a probably annual or biannual basis, but they don't have to, but they might, and most organizations do sort of an audit or a review against the NIST CSF, which is the Cybersecurity framework. And now organizations are also adopting the AI risk management framework. And these frameworks are made up of over 138 controls, and they're incredibly detailed. And they look at everything from governance to incident response. And then they have layers underneath those where there are further controls. So you're going and you're looking at things like IDAM, so identity and access management. You're looking at things like OT. So they're incredibly detailed controls. And that's what that function will be looking at. And what's interesting from this perspective, from the new, this has just come out and it took them sort of 2 years to produce it, is they've put governance at the heart of it, then measure, manage, and map. And what's really interesting is, again, traditionally, one more question, who's familiar with IAPP? So they're the data privacy guys. So they essentially set standards for data privacy. So what they've done is they've made a clear distinction between traditional cybersecurity and AI security. And what we're talking about today is AI security. So traditional security will deal with things like networks, right? AI security is sort of a new space, and it's dealing with slightly different themes and challenges. And the problem is that traditionally, developers, engineers, even security teams, we've not been taught about these things as part of our roles. And suddenly there's an expectation to build securely, to design securely, to engineer securely. But actually, it's really difficult to know where to start with those things. And that's where we come in and we support. But security, I mean, I can't stress it enough because I work in security. So you always see what happens when security isn't embedded is incredibly important. And I think if you literally go on Bing, not Google, because I'm in the Microsoft office. If you go on Bing every day and you just put in cybersecurity, you'll see on a daily basis where there are cyber attacks across national infrastructure or across private sectors or things like CrowdStrike happening or whatever. You'll see cyber incidents happening across the board, although I don't think CrowdStrike was more of a coding thing, but we'll drop it in anyways. You'll see business continuity and operational resilience problems. I'm enjoying the nodding from Liam in the corner. So next one up, gosh, a picture of 3 Labradors. You guys are really getting spoiled here. So you had a picture of 1 Labrador, now you have 3 Labradors. I thought that would get more of a reaction. I'm slightly disappointed, but it's okay. I have faith that other images may get a better reaction. Now we're going to move on to EU AI Act. We're not going to go through the whole act. No one's got time for this. But what are we going to do? What I've done here is I've put it into I've segmented it into where security is essentially called out. And so we have this chunk here, and all these lovely chapters focus on things like accuracy and robustness, explainability, logging and monitoring, resilience, identity and access management, risk mitigation. These 2 chapters are looking at safeguarding and testing, streamlining processes, value-adding service. This little bit here looks at GPAI models, product safety, cultural awareness. Here's a question. How often do you think about cultural awareness from a security perspective? So I think it's a crazy number. It's definitely above 70. I think it might be 90. But the figures are pretty high for actually how the majority of security breaches are just human error. So you can code as much as you want. You can put as many security controls in place, but your people are as much your asset as they are your liability. So that's been called out also. And then here we've got data protection, confidentiality, and information exchange. Now, next we're going to look at another really serious slide. Oh, no, we're not. I'm sorry. This one's smiling, but not much of a reaction. That's okay. Now we continue. What's really interesting about the classification of AI systems according to the EU AI Act is that it's not just been classified according to the AI tool. It's also being classified against the actual use. And what that means is you could have an AI tool which is relatively low risk, right? But if the application is deemed as being particularly high risk, it might actually end up falling in this bucket. So this is sort of the approach that the EU AI Act have taken, and it's a really interesting approach. But we've also seen things around unacceptable risk, high risk, limited risk, minimal risk. But I mean, and there are examples of this, but things like unacceptable risk will be a social scoring system, which uses AI, which I'm sure we can all think of an example where individuals in a country might be scored according to their behavior, and then that impacts their financial purchasing power. That's deemed as unacceptable risk. And then things like high risk look at critical infrastructure. So again, the AI tool doesn't necessarily need to be a high risk AI tool. If the application is going to be within something like national infrastructure, security is being considered quite highly in that space. And so we're also seeing a lot of organizations going, how do we tick the boxes from a DD perspective, right? From like a due diligence perspective, because we want to do this work, but we don't currently tick these boxes. And then when we're looking at limited risk, that's looking at things like a lack of transparency in AI usage. And then finally, minimal risk is looking at things like free use of minimal risk AI. So this includes applications such as AI-enabled video games or spam filters. I actually saw an advert for World of Warcraft recently, and I think they were talking about using AI or AI-powered stuff. And I remember thinking, gosh, those animations look a lot better than when I played it about 1 million years ago. So that's definitely a great use of AI. Right, I think that might actually be our last Labrador picture, and I'm very disappointed there's no laughter in the room. But they're puppies. Are there no souls left in this room? Thank you. Now, let's take a look at what the risks look like and what the use cases look like. Now, these are all real. So the first example we'll look at is a deep fake, and that's the one that was called out by Ofcom. And so this happened back in 2019. CEO of a UK-based energy firm was impersonated using a deepfake audio technology. They were essentially conned out of, I think, around 200,000 euros. They never got the money back, or at least not from what I can see. Next example is in the automotive space, and that was an autopilot crash. So what happened was there were multiple incidents where automotive companies were using an AI autopilot, and yeah, there were several crashes, which was terrible. None were fatal from what I saw, but that was quite damaging. Next up was a global software giant chatbot. So global tech companies' AI failed to moderate hate speech and misinformation during a period of elections. And then finally, a tech company breach. So an AI company which scrapes data from social media. Who's familiar with data scraping and web scraping? Yeah. I expected your hand to go up, Liam. For facial recognition, data experienced a breach. And actually, I think that company also operated in national infrastructure space and in defense. So that was a particularly sort of severe breach. Now, what do these all have in common? I'm going to pretend like you didn't see it. And I'm going to get people to tell me what they think they all have in common. So what do you guys think all of these have in common? I will pick on people. I don't care. It's fine. Someone will put their hand up and tell me what they think. No one feel bad picking on people. Yes.
All of them could have been mitigated with the right rules in place or not.
Yeah. Yes.
Yeah, I guess AI could be adapted to leverage these security breaches.
Amazing. Liam?
There's no validation from a human on the flip side of it.
That's a really important, that's something really important to call out actually, because there have been a few incidents in the UK within government where I think one of them was DWP, right? Where there was no human in the loop, and actually where there was a human in the loop, but it was very high level. I don't think they were particularly trained, or maybe they were trained, but there was just, it didn't end well. It's actually, I've got a link to it if you want to read up on what happened, but it wasn't great. But another example of that was in the Netherlands, where the government again used an AI algorithm to spot fraud among people that were claiming benefits and all that stuff. And children were eventually separated from their parents who hadn't actually committed fraud. And that, I think, went to the High Court. So what do these all have in common? So a loss of customer trust, brand erosion, financial loss, a loss of public trust, operational disruption, reputational damage. So actually, we want to leverage AI. And how do we leverage AI? But we also want to think about security, because whether we choose to leverage AI or not, from an adversary perspective, AI is already being leveraged. So how do we improve our response to emerging security threats? Now, what do potential applications for security look like? So some of them look like anomaly detection, threat intelligence, code scanning, vulnerability management, but the list just doesn't stop here. There are so many possible applications for AI to tackle security threats. I actually don't have any more Labrador pictures. I really don't. I think most people didn't believe me when I said that. But if you would like to get in touch, this is my LinkedIn. This is a free newsletter. That's a free consultation. If you work in an organization where you're not already thinking about security, get in touch with us. And then this is a link to the upcoming AI security workshop. So definitely get in touch. Thank you so much for listening. I hope everyone enjoyed it. So yeah, I'll open up to the floor to any questions.
Yeah, I've got one question. How difficult, probably lots of people know that blockchain very secure. People trying to use Bitcoin for mining and everything. how difficult is to adopt AI security into blockchain? It probably will be even more secure if developers will do not. I heard major companies just started to do these things, but it's not like common use for just ordinary companies. That some companies are going to tell me that it's not possible at all.
Yeah, I think that's a great question. So from our perspective, we're having sort of conversations with, we've actually got a meeting coming up with a blockchain startup, right? And they sort of posed that question to us. But what we're seeing is that what's happening is that companies are using blockchain, but it's not their blockchain, it's a third-party blockchain. And then they're often the customer user sort of interface to it. So they don't have any powers to really impact that. And from a security perspective, it's difficult because it's built on the basis of being a decentralized system, right? So it's difficult from a security perspective to integrate. We don't work on the technical integration, but what we do is we help organizations to identify what the gaps are from a security perspective if they do want to use that technology. But from an integration perspective, I'm sure it's very difficult, but we do not work across technical integration. Yeah.
Awesome.
Cool.
So I think most of you have a physical key to your home, right? Now imagine now that Rav is a locksmith, right? And today he says it's completely free to take whatever key you find and make a copy of it. Now imagine I do this. I step away for 5 minutes just to see how many of you would actually say, Chris, I bet he has some nice things at home. Maybe a laptop, maybe a Mac, maybe some candy, maybe some cash. Now, you might not actually take these physical keys and go to Rab and take her up on her offer, but a lot of people on the internet will. Now, so just imagine what this key could access, right? It accesses my house, right? Or whatever kind of property. And that's what I want you to think with keys. They have master level access to everything. And that's why physical keys, API keys, are a problem. Now, of course, API keys are software keys, right? But if you think about them as physical keys, then you understand why we need to be careful. So that's what today is about. To say, well, if you're using API keys, try to move away from that, and hopefully I make a good job out of saying, what should you move to? Now, how many of you are application developers? How many have ever dealt with an API key? Right, so a few hands. So you know what I'm saying when I'm saying an API key, but let's try to be a bit clear. So this is today's talk. First, I'm going to talk about why API keys are a problem. Hopefully you're on the same page as me, thinking about API keys like physical keys. But then we need to talk about managed identity, because unless you're an Azure developer or you deployed on Azure, you have no idea what this means. So how many have heard of managed identity? One hand, a couple of hands. Then I'm going to show you a practical example of using managed identity so you kind of see how it works, right? Because we kind of need to build that mental model. And lastly, we'll try to do a recap just to see, okay, now with this newfound knowledge, what do we do? So, as Liam said, I'm on a JavaScript team, so therefore I'm showing you some JavaScript code, but this might easily be Python. What I wanted to highlight is, remember the physical key I showed you? Now, imagine that this is part of your source code, right? You have an API key, some kind of access towards an API, or some kind of resource that says, yes, Chris, I will let you in. And then you are using that very same key as part of the header in which you make that web request. And they say, yes, Chris, I recognize you. You should get the products list that you're asking for back. Or it might say, you know what, I don't know who you are, or I might know who you are, but you definitely shouldn't have access to this data resource. So that's where we are, right? API keys. Now, I want you to really think about this sentence. It's a scary sentence, right? 35% of all exposed API keys are still active. Think about that. So of all the data breaches, a lot of these keys have not been rotated. They have not been replaced, but people are actively using these keys to steal your secrets. So yes, security is important. And as application developers or the person who is somehow responsible for an AI system or an IT system, you need to know this. You need to have a good plan in practice for what happens when I'm breached. How can I ensure that I'm using the best level, best practice when it comes to security? You need to have a plan for that. Now, so what is the problem then with our API keys? I think I alluded a little bit to it, right? I said API keys. Okay, someone else can copy that. But exposure, right? How many knows what GitHub is? How many have pushed some kind of code to GitHub? How many have pushed an API key to GitHub? My hand is still up. Shit happens, to be honest, because it does, right? We sometimes we're just humans, right? We push code to GitHub that we didn't mean to, and it's a public repository. And you know what? Within the next 3 minutes, you can toss that key, because there are scripts running about on GitHub that will collect this key and will try to access your system. So you need to be in a mindset so that you know how to rotate that key, how to replace that key towards a new key, so you render that old key useless. Right, so imagine then, I wanted to make this into a conversation, right, rather than a presentation. So imagine now that someone says, well, can't I rotate my keys often? A lot of people do this. A lot of people rotate their keys maybe every week, every month, just in case, right? But definitely after a breach. But it definitely decreases the risk. But keys are problematic because you have full access usually, right? When you get access via an API key, it's like, I can do all the things. I have admin level access. I can delete your repo. I can add things to it that shouldn't be there, and so on and so forth. So that's a huge problem. Now, the other bit is that they're static, right? And what do I mean by that? I mean, imagine that you have an API that you want to access, right? And then it's a very static process to come to a point where you need to change them. So imagine now that you have a data breach, right? You have a data breach, and you just need to be fast enough, because just imagine that you know that there has been an exposure and you need to act within the next 30 seconds or maybe the next 5 minutes because you're working at the bank, and you know that exposure for every second people will be able to do something because they will attack you with scripts that will be super fast. So if it's a static in nature, you need some kind of system in place to just quickly replace all the things, quickly rotate all the things. Sorry, I just need to shut this off. Now, the other bit I mentioned is that API keys usually have full access, right? That means admin level access. That means that you can't even control if you should have access to all the product lists, or maybe write towards a product resource, maybe just read from it, and so on. Usually with security, you need a very fine level of access. You want to make sure that you can define different roles. Who's the admin? Who's the person that should be able to change products but not orders, and so on. So you need to have all that plan in your head for your IT system as you build it. What roles do I have? What permission levels do I need? And you're not going to get all of that with an API key, but you need something else. And we usually refer to this as RBAC, role-based access control. I see a few nodding heads, so I think you've heard that term before. Now, storage is not a problem, right? Are we storing our API key in such a place that it's deemed secure? And what I mean secure is it in the cloud? Is it in a file somewhere? And definitely, is it encrypted, right? Because you want to have some kind of vault to make sure that whatever secrets you have, whether it's an API key or something else, it's stored in a secure way. Now, if you're on Azure, that usually means Azure Key Vault. But if you're using some other cloud vendor, then there's a corresponding service for that. But the point is, you don't want it in your source code, and you don't want it in some loose file that isn't encrypted. And then you got this problem, secret sprawl, we call that. So imagine now that you are reusing the same API key in many different services, and you have that breach, right? You need to go to your order service, your product service. Everyone's using microservices these days, right? So there's a service for everything. And maybe there's a service somewhere in your landscape of hundreds of services where you forgot, oh yeah, this service over here that no one's touched for 3 years is using that API key that's breached, and you forgot to replace it. So do you know in a bigger company exactly what services are using which secrets? And do you understand what you need to do once you replace that key? So you need some kind of automated system, right? Because it's going to be hard for you to replace this fast enough once you have a breach. And even if you don't have a breach and you just want to do this on a weekly basis, you still need to do an inventory of all your APIs. Right. I have puppies too, right? So all of this is problematic, right? And because data breaches, I mentioned that, but it's not just having a breach, but it's what that breach leads to. Because sometimes, as long as they're inside the door in your house, then they can just escalate and say, well, I came in here as this level access, but now I'm actually widening my access, right? So they can do a lot more and a lot more damage. That's usually what happens to a lot of companies, right? People are being let in through the door and then they wreak havoc in there because they escalate themselves towards admin level. So that's also a problem. And of course, service disruption, right? If they really want to break something in your systems, they can, because they have that level of access. Just remember that data breach, privilege escalation is what we call this one, and then disruption. So how do you deal with all this, right? I guess, okay, now I kind of scared you to a point where, like, why do I even use the internet, right? But how do we address this? Well, you got OAuth, right? It's an open standard for, delegating things, for storing secrets securely. And as we said before, if you must use API keys, and I'm sure a lot of your systems will still do so for a time, make sure that you at least rotate your keys, or, as I will show you in the upcoming slides, apply your cloud vendor's best recommendation when it comes to how do you manage identity. So let's talk more about that. What does that mean, the best recommendation from the cloud vendor? Managed identity. How many hands have heard of that? Right, a few hands. So you did hear that term before. That's great. Let's talk about what that means. You can almost hear it in the name, right? Managed. That means that I don't have to do it. You're like, oh, no longer my business, right? So the idea is that you are able to gain access to various resources in the cloud by not using API keys, but instead using the concept of an identity. So that means that certain applications on the cloud are able to use what we used to call Azure Active Directory, but now it's called Entra, and the whole series of products within Entra. There's Entra ID, there's Entra External ID, and yeah, quite a few products within the Entra umbrella. So that sounds kind of good, right? You don't have to generate the API key, but you do need to create or at least enable identities so that you can use them to securely talk to cloud resources. And that means that you're solving for two major situations, right? One is you as a user talking directly to a cloud resource, but also cloud resources themselves talking to other cloud resources in a secure way. So it's like system to system, but also user to system. But of course, in the cloud, there are different types of managed identity, and you need to kind of identify your use case so you understand which one should I pick. So two different ones. One of them is called system assigned. The other one is called user assigned. So system assigned means that you're tied usually to a specific resource. So if all you need is to talk to this resource and nothing else, system assigned is probably a good idea. However, if you want to talk to and share this across several resources, you should probably have something called user assigned. And this is a selection you do once you create that identity. You create it and you select which type. So once you've done that, once you understand your use case, you select the one that fits your situation. Now, how does all of this work, right? I mean, I said, okay, there's no API keys. There's a managed identity instead. What does that mean? It means that I present some kind of credential. When I try to access a resource, I talk to Entra and say, hey, here I am. And Entra answers back and say, okay, I recognize you, Chris. Here's a token, right? It's almost like a physical movie ticket. Here's a token, take that token and identify yourself towards other resources in the cloud. Now, of course, those resources, if they're configured properly, will say, I accept this token from you, Chris, and I will give you access. But as I said, those two are needed, right? So you need to do the Entra setup so you can get that token in the first place, but you also need to enable the other services. And sometimes you even need to add a role that you need to have for this identity. But I'll show you a concrete example. And of course, validation is what happens, right? You can't just wave with a token and say, let me in, right? But you actually need to make sure that that token has the permission levels on it that it should have. So once that validation happens, it says, yep, you have access to my key vault here, take your secret, or you have access to my storage, here's your video file. So let's talk about the practical example, right? Because all of this sounds a bit theoretical. Okay, I kind of get it, Chris, right? I shouldn't use an API key. I'm using this other concept of managed identity. I create the identity, but then it's managed. Okay, right? So let's look at a practical example. We all have seen this kind of interface, right? Some kind of ChatGPT-like interface. You send a prompt, you get a prompt response. So Azure OpenAI, very common thing to use on Azure, or if you use ChatGPT. You want to talk to that large language model, you want the prompt response. How many have heard of API management? No one? No idea? You have? That's why we call it. Now, so jokes aside, imagine that you have lots of APIs, hundreds of API endpoints, and you're like, at this level, you think differently, right? If you have one API, you're thinking, I better secure that API. But if you've got hundreds of API, you start to think in terms of groups and permission levels. Maybe this group of API, maybe these 20 APIs need the same kind of policy. So that's what you're saying, right? So it's almost like on company level. You're saying like, okay, all of these apps can access these APIs with this kind of security level, but these group of apps have this access level instead. So then you get a sense of it. And also imagine load balancing or you're capturing some kind of stats, how your APIs are doing. Are they healthy? Are they erroneous? And so on. A lot of these things, you don't want to write code for a lot of these scenarios, right? But rather have, on a very high level, you want to configure. And that's when API management comes in. So the idea here is to take Azure OpenAI, because you know what you want from it, put something in front of it. And once you do that, you're able to rest easy because you know that, okay, if there's 100,000 people using my app, I have this service here that is able to manage that. It says like, okay, I'm going to send 20,000 of you in this direction and 40,000 in that direction. And you were here 2 seconds ago, so get out, right? And of course, that's what I'm saying, right? You're able to apply all these different policies, these intelligent behaviors, so that you can route all of these people around. So what I'm saying is that we will also use managed identity in this case. And this kind of varies depending on which Azure services you're using out there, because sometimes it's very easy. It's just enable the identity and you're good. Sometimes you need to do a little bit more. So let's look at this specific example. So you got your Azure OpenAI, right? You can send prompts to that, you get a prompt response, but now you're thinking, okay, I actually going to have 100,000 users in front of this that's going to use this. I'll probably put something in front of it. I land on Azure APIM, that we call it. And what I'm saying is, for APIM to be able to talk to my service, so this is system to system, the first thing I need to do is to enable managed identity, right? So at this point, I've actually created an identity that actually represents APIM, right? But at this point, it can't access. So for the access to actually happen in a successful way, what we also need to do is to add a role. We need to say, you know what, APIM, you need to have a role called Cognitive Services User. If you have that, and you're also in the same scope, and scope can mean resource group or that exact resource, you have the role, you have the identity, you're in the correct scope. If all of those three checks out, yes, you can talk to my Azure OpenAI endpoint. So as you saw, there are usually 2 or 3 things that you need to do. Enable the identity, add the role, and make sure that they are in agreement on what kind of scope. So at that point, it's almost like if you imagine a physical situation. It's like, yeah, if you're my friend, if you're wearing a red hat and a blue sock, then you're allowed to step in through the door. And how you usually enable the identity in the first place is that you go to Azure Portal. So in this case, I've gone into my API management service. So now I'm doing step 1, right? I'm stepping into the security tab here in managed identities, and I'm just going here and just switching this from off to on. So at this point, I give it a signal to say, create that identity for me. So now it's creating that identity, which means it's also going to create a couple of keys on that identity that I will be able to use later as I do that role association, which is on the next screen. So now I'm heading back to Azure OpenAI, right? Because I've done my part on APIM. So now I'm going to Azure OpenAI, and now I'm saying, you know what? I will add the cognitive services OpenAI user on the APIM. So now I'm saying like these two services can talk to each other because I enabled managed identity, because I added the correct role. But of course, this is not the only way to deal with managed identity. My point was just to establish that there is such a concept called managed identity, and it differs a little bit per service how you use these things. So there is alternate flows. So imagine that you have another flow. In alternative number 1, you go to Entra itself. So at this point, you register an app. And what we say when we register an app is that we have the notion that we have an application. That application probably has APIs. That application probably has a login and logout flow. So that's the mind space we're at, right? Or headspace. Now, in alternative number 2, we're saying we're not actually a physical user, but we're more saying we have continuous integration. We have a pipeline. Do you know what that means? You have a piece of code. You set up a pipeline. So before that thing goes live, you probably want to do stuff as part of that pipeline, like testing the code, like checking it for irregularity. Then you need to package it, and then you deploy it. That's what we mean by a pipeline, right? We set up a set of actions. So at this point, we're saying you probably shouldn't use an Entra app registration because we're not technically an app, but we're rather a system user, right? So there's one of two ways then here, except for the one that I told you about, how you can also generate that initial identity. That's what I'm saying here. Select the best use case for generating that identity. And once you do that, again, you need to add that role. You need to tell Azure OpenAI that I'm actually the type of user that's allowed to talk to you in the first place. So keep that in mind if you are building apps on Azure, that there are different ways of creating these different identities for you. It might differ a little bit per Azure service, but my point is still, don't create an API key, enable that managed identity, and make sure that you identify which Azure service you're dealing with, so you understand if, should I be adding this role or some other role, right? Because this role might differ per service. So with that said, let's try to summarize what we've been saying so far, right, as part of this talk. API keys, good or bad?
Bad.
Bad. I hear a few bad, a few, yeah. If you must use keys, rotate. So please do this, right? And rotate just means that we want a new set of keys. We're saying that the old keys are bad, don't use them anymore, they've been breached, or they're just too old. And managed identity, how many think they kind of understand what that is now? Great, a few nodding heads, fantastic. Use managed identity if you're using Azure on your resource, and it shouldn't be harder than enable that resource, maybe add a type of role, and then just talk to it and know that whether it's user to service or service to service, there's a bit different tactic that you need to use. So either make sure, am I creating a principal? Am I creating some other type of identity? But the message I want to convey is really, there is an identity in the cloud. It's managed by the cloud, not you, right? But you're still going to use that identity, and then you just need to make sure that, hey, service A can talk to service B. So once you figure that out, go on to deploy your app, and now you can say, I can actually sleep good because there's no API key involved. It was not my fault, whatever happens. So with that said, thanks so much for listening. Any questions at all on this? Super clear? Yes.
API keys, is it useful to have backup of API keys? And if, like you said, you have like hundreds of API keys, why or how